Question 4, we are asked to supply all missing values for each table. Part A says this is an arithmetic sequence. Okay, so if it's arithmetic, that means I'm adding the same thing again and again. So I'm going to jump from A to 72 by adding the same number twice. And I can figure what that number is. I can calculate that number by calculating slope, right? If I go 72 minus 8, I know that I did a jump of, 72 minus 8. It's a 64. And over here, if I take 2 and I subtract 0, I can see I increased by 64 in 2 steps, right? So 64 divided by this value of 2, 64 divided by 2 is the number 32. So I'm adding 32 each time. 8 plus 32 is 40, plus another 32, plus another 32 gives me 72, plus another 32 gives me 104, plus another 32 gives me 136, and then plus one more 32 is 168. So we are growing by 32, and I filled in the rest of the table. Next it says, write an equation in the form y equals mx plus b that fits this table. Well, this is beautiful because I can see I see where x is 0, right? Because where x is 0, that's my y-intercept right there at 8. So this equation's going to be quite nice. It's y will equal, I'm growing by 32, so every single time x increases by 1, we add another 32. So that's why it's 32 times x, and then plus our y-intercept lives at 8. So this equation does a fabulous job of giving me exactly these values. Something we can see on our calculators too, and I probably don't talk about this enough, is on this calculator, if I was to come in here and turn it on and clear this and look at y equals, I have the ability to type an equation here. So I can type in 32. This button will give me my variable x, so 32x, and then plus the number 8. Enter. Now that I've got this equation typed, if I want to see this as a table, I can see right here in blue it says table. If I hit second table, it will show me that. And check this out. At 0, I can see 8. 1, I can see 40. So you can see 8, 40, 72, 104, 136, 168. The next one's 200. So I can see on this table in my calculator, it matches exactly the table that I've recorded for part A. Kind of a nice tool. Let's move on and do B. So B says this is a geometric sequence. Oh, okay. So if it's a geometric sequence, instead of adding the same thing, right, I'm growing by multiplication. In fact, if I think about this, if I take the number A, I multiply it by B once, and I multiplied by B again. So 8 times 2 factors of B is going to give me 72, or I could say 8BB, 8B squared is 72. If I divide both sides of that by 8, I get 72 divided by 8 is my long time. Do I have any long time friends? I don't have any long time friends, but 9 times 8 is the 72. So I get that B squared is 9. And of course I know that B has to be 3. But I want to remind you, sometimes the power could be different. So how do we proceed if it's not that number, right? So let's check this out. If on my calculator, certainly the square root of both sides is going to give me 3, but also check this out. If I raise both sides of this to the 1/2 power, right? B to the 1/2 power is going to give me just the variable B. But if I take 9 and raise it to the 1/2 power, check it out. 9, not the letter Q, 9 to the 1 divided by 2. 9 to the 1/2 power is 3. So you can see that B is indeed 3. Now, what's beautiful is because we are provided again with x is 0, we know that this is our 0th term. right? So I've got my 0th term is 8, my multiplier is 3, so the equation is y equals ab to the x power a, my 0th term is 8, my multiplier b is 3, and then to the x power. So that's my equation there. I can get the missing values a couple of different ways. If I clear the screen and I start with the number 8, got it, and I just hit times 3, I can see the next value is 24 times 3 gives me 72. The next one is 216. The next value is 648. And then the last value is 1944. So another way that I could do that too is I could enter that in my y equals also. So if I hit second y equals, nope, second y equals, no, come on, clear. Oh, I just hit y, I don't hit a second, y equals. I can come down here and I'm going to enter a second table. I'm going to just go 8 times 3 raised to the x power. Doop. So if I look at this on it as a table, I'll hit second table. You can see these values over here when I was treating this like the geometric sequence, and you can see 8 becomes 24, becomes 72, becomes 216, becomes 648, becomes 1944, becomes, well, after that it would be 5,832. So we got it. We took it was just two points on a table of values, and we were to create both an exponential and an arithmetic, right? A arithmetic sequence and a geometric sequence. Let's move on.